Hello everyone, good morning. Inshallah, we will start our lecture today. As I told you previously, we will go, I'm sorry for the ice cap that I'm wearing, but it's really very cold today. Okay? So, as I told you previously, we will continue today to a very important topic, which is the coordinates. This is the content that we are going to cover today. It's actually covering lectures 3 and 4. I'm a little bit behind Lisbon, but we are in a very good shape compared to the previous year, okay? To the lectures in the previous year. Because in the previous session, we succeeded in completing plenty of stuff regarding the shapes of quadratics, and will help us a lot in the next slides and in the coming topics. As I told you, we are in the analytic geometry part and we are in coordinates. This is the part that we are going to go through today, inshallah. Introducing our introduction to three-dimensional space, the first thing to have is to have a coordinate system. The coordinate system that we all know is the Cartesian coordinate system. What's the Cartesian coordinate system, Mr. Faisal? The Cartesian coordinate system is X, Y, and Z. So if I want to reach any place, in the space, all I have to do is to consider this is the X-axis, that's the Y-axis, and that's the Z-axis. So the positive right hand or the right hand, it reflects the positive directions in the X, Y, and Z. So if I'm moving from the X positive direction and going to Y positive direction, your thumb will be for the positive direction with respect to Z. Okay, that's the Cartesian, or the simplest thing about the Cartesian, as I told you. The coordinate determine the X and Y axes, and the XY will have what is called the y1 or the XY plane. So this part, it is y1 or the XY plane, and you will be moving away from the y1 by moving up through the Z axis, as you can see. Also, we have the YZ plane, and I believe in the previous session we spoke about this. Once you saw the coordinate planes, the XY, the YZ, and the ZX, of course, Faisal, that's the ZX plane, this is the side plane. By the idea, also reviewing to what we had previously, the XY plane is the plane with Z equal to 0, and the YZ plane is the plane with X is equal to 0, and the ZX plane is the plane with Y equal to 0. So what's the equation of the XY plane? Z equal to 0. What's the equation of the ZX plane? Y equal to 0. The missing one will equal to 0, and that's the equation of this plane. So it's very, very nice, as I told you, and very easy to follow up with. Okay, so once more, as I told you, once more, this is the Cartesian coordinates, as you will see. Okay, also to reach the any point in the Cartesian, I will move a distance x on the x-axis, as you know, then parallel to y, I will move the distance y, then I will go up parallel to the z-axis and get my point. This is how we move through the space. So we determine the origin, which is the reference point. To reach any point in the space, the Cartesian, it's very, very simple. All you have to do is to move a little bit units on the x-axis, move a little points on the y-axis, then move up on the z, or move down according to the sign that you are following, okay? So, once more, as I told you, if you look to, I will get to this later, but I will show you an example. But also from the stuff that we really need, or we will need in the future, is the distance between 2 points. The distance between 2 points, it's simply the difference between their coordinates squared under square root, which is the norm. If you remember in linear algebra, that's the norm of a vector. What's the norm or magnitude of a vector? What's the norm or magnitude of a vector? This is the square root of the square of the coordinates. Are you with me, Faisal? Now, I'm getting the difference just only between B1 and B2, or B2 and B1, it will make no difference, but just once you start taking the differences, x2 minus x1, you will have to continue y2 minus y1, z2 minus z1. Also, it will give the same result if I follow this ziyad x1 minus x2, but in this case you will have to continue y1 minus y2, z1 minus z2. Okay? Very good. That's the distance between 2 points. Here he is asking you the distance between A and B. And it's very, very simple. All I have to do is to get the difference, whatever you like. So I would say 3 minus negative 1, which is going to be a 4 to the power of 2. Then 4 minus negative 3, which is going to be a 7 to the power of 2. Then negative 2 minus 1, which is going to be negative 3 to the power of 2. Under the square root, so you will be able to get the distance between these 2 points, which is root 74, if needed. Okay, so actually in exams or something, it's going to be rare to find a question about finding the distance. You know what I'm talking about. But in some cases, if you need to, you will be able to. If you need this distance, you will be able to grab it. Okay, those 2 points, this is how to reach these 2 points. Okay, so if I want to reach the point 3, 4, negative 2 in the space, what I have to do is to move just 3 units on the x-axis, then I will move 4 units on the y-axis, then I will go down 2 units to reach my point, that's point B. If I want to go for negative 1, negative 3, and 1 in A, so the first thing to do is to move negative 1, here we go, that's the x-coordinate. Then I will move 3 units parallel to the y-axis. Then I will go up 1 unit and to reach point A. This is how to reach points in space, as you can see. Okay, how to get a midpoint between 2 points, just in case if you need this in the future also. It's very, very simple. All I have to do, instead of getting the difference between the coordinates, add the coordinates on each other, then divide by 2. So all I have to do is to add x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2, and then you will have your midpoint. So if I have, this is A and B, and if I want to get the midpoint, it's very, very simple. 3 plus negative 1 over 2, 4 plus negative 3 over 2, negative 2 plus 1 over 2, and that's the midpoint between these 2 points. As I told you, plenty of these knowledge, it's a tools. If you need it in the future, you can grab it. Okay? Okay, now we are going to a very important topic. I will talk first about the points or the points in the XY plan or in the plan. So any point in the plan, if I have a point in the plan, like this one, let's say this is B, which is x1, y1. All I have to do is to move on the x-axis a distance x1 and to go up y1, I will get this point. There is, of course, the polar coordinates, which is applicable and has a lot of applications, and it is easier to use. The polar coordinates will go like this. It will depend on 2 coordinates, which are r and theta. So I will move with a specific length with the edge of a specific angle. My angle will be open from the positive direction of the x-axis and above. From this point of view, R belongs to the set for R positive and 0. From the previous lecture, now you know that R belongs to the set starting from 0 up to infinity. So R actually starts from the 0 and to go up to infinity, okay? And this R will be moving in anywhere using a theta. Theta will be open from the positive direction of the x-axis, and it will give you the exact place of any point in the plan. So, according to this, the relation will be x is equal to r cosine theta for the x coordinate, and y will be equal to r sine theta for the y coordinate. And also, according to fifth green, that r is equal to the square root of x squared plus y squared from this right angle triangle. So, and the theta is equal to tan minus 1 y over x. Those are the relations that I will use to move from the Cartesian into polar, and vice versa, from polar into Cartesian. So if I have the Cartesian coordinates, I can easily move to polar coordinates. And if I have a point in polar coordinates, I can also get back to the Cartesian very easily, as you will see, using these relations, as we will see in the coming slides. So, as you can see, it's very, very simple. A system of polar coordinates in the plan is defined as 0 belongs to R3, and the array containing at point 0 pole, the reference point is called the pole or the line segment tray. From the pole, it's called the polar axis. Okay. In polar coordinate systems, the origin is called a pole. This is r theta, and that's explaining all what I've tried to explain for you. The relation connecting them is x equal to r cosine theta and y equal to r sine theta. This is how to move from polar to Cartesian coordinates simply. And of course, r running from 0 up to infinity, and theta will go from 0 for the positive direction of x-axis to 360, and this way you will cover the whole plan. So the idea simply is to cover the plan. So if I am in the xy plan, I need to cover it. I will cover it through the x-axis and the y-axis. I'm going to cover it. Or imagine from 0 up to infinity, but with an angle of 360. So it starts from 0 and go to anywhere. Okay? Any questions? Okay. Very, very, very important system that we can use. Usually in this system, I imagine that this is R and you are moving with theta to reach a specific point. Okay. As I told you, that's the opposite relation to move from Cartesian into polar, and this is tan theta. Remark that I'm dividing the y coordinate on the x coordinates, and of course x doesn't equal to 0. Here he's asking you, consider the point with the Cartesian coordinates root 3 and 1. Determine the polar coordinates of B. I need to determine the polar coordinates of B. So all I have to do, I have x and y, I will get r. R is equal to x to the power of 2 plus y to the power of 2 under the square root. So all I have to do is to get this, make a substitution in this relation. So it's going to be root 3 to the power of 2, which is 3. Plus 1 is going to be 4. Under the square root is going to be 2. That's 4r. And the 4 theta is going to be tan theta of y over x. Those are the parts that I want you to memorize. Tan theta is y over x. So I'm going to divide 1 over root 3. So 1 over root 3, I believe it's going to be pi over 60, which is 30. Now I have the same point. Remark that these two coordinates are in the first quadrant. So theta also will be pi over 6 because it belongs to the first quadrant. So for root 3 and 1, now I knew that the corresponding point in polar coordinates, it's gonna be 2 and pi over 6, as you can see. That's the point that in polar coordinates and in Cartesian coordinates, as I told you. So if we continue, hence the polar coordinates is going to be 2 over pi over 6, as I told you. We will consider the following subsets of R2 in Cartesian coordinates and characterize them using polar coordinates ومديك equations. من هنا زي ما قلت لك, it is the start of problems that maybe you exposed to it in your net terms or your final exam. So if I'm looking to this relation, A is x and y belongs to r square, which means, why r square? Why x, y belongs to r square? Because 2 dimension and the x will go belongs to r and so on. And such that the root of x squared plus y squared is equal to 2. What's the representation of this equation in polar coordinates? Before we go to polar, you already attended the previous session. So Ms. Jana, the root of x squared plus y squared equal to, what's the shape of this equation, or what does it represent? If I square both sides, I will have x squared plus y squared equal to 4, which means an equation of a circle with radius equal to 2, and the center is the origin. This is why we had the previous session covering all of this. Okay, in this case, a circle is the best equation to be represented in polar coordinates. Because simply, if you remark that r in polar coordinates is the square root of x squared plus y squared. So now I know that it is r equal to 2. That's the equation that I'm talking about. So I can write it like this. I can write that A is the set of an x and y such that r cosine theta, r sine theta, and such that r is equal to 2 and theta is running from 0 up to 2 pi. So now I've explained to everyone that's a circle with radius 2, okay, and theta, there is no regression on theta because it will cover the whole circle, okay. So once more, I can do this exactly as I told you. I can cover it exactly in a similar way. So simply, it's gonna be like this. As I told you, once more, the condition is root x squared plus y squared equal to 2. So I'm talking about a circle with radius equal to 2. There is no, so the xy is equal to r cosine theta, r sine theta, such that r is equal to 2 and theta is running from 0 up to 2 pi. So that's the complete circle. طيب تعالوا نبص على another problem. That's another problem. Problem number B, which is x and y belongs to r square such that y is equal to root 3 of x. I want to get or characterize this equation but in polar coordinates. So it's an equation of a straight line. صح؟ That's an equation of a straight line passing through the origin. مش كده؟ طب لو r theta تبقى عاملة ازاي؟ Just to make a substitution. Are you with me, Ms. Jana? I will replace x by r cosine theta and y by r sine theta. So I can easily move from the Cartesian into the polar. Simply a face-off by using the relations, connecting both of them together. So all I have to do, guys, is to replace y by r cosine theta and the x by r cosine, y by r sine theta and x by r cosine theta. So as I told you, this is gonna be, of course, if I did this, this is gonna be r sine theta, and it's equal to root 3 of an r cosine theta. If I try to arrange them, the r's will be vanishing with each other. I can bring root 3 on this side. Here we go. And this is gonna be cosine theta by sine theta, which is tan theta, as you will see. So now I can get the angle, which is actually theta equal to tan minus 1 over root 3, which is pi over 6, as you saw previously. So all I have to do once more, as I told you, this is y equal to root 3 of x. I will replace y by r sine theta and replace x by r cosine theta. Really done? Or use directly tan theta is equal to y over x. It's up to you. So I've already did that. So y over x, which is root 3 over 1. So tan theta is equal to root 3. And in this case, once you get tan minus 1, you will have theta equal to pi over 3. Because pi over 3, do you know why it's pi over 3? Do you remember the 360 triangle? Of course, there is two major triangles. You shouldn't ever forget. The first of them is this guy, which we will depend on it on plenty of problems, or in order to cover that you can solve without your calculator. So if this is tan theta, okay, and this is equal to 30, this angle, which is pi over 6, of course, this is gonna be relative to pi over 3, which is 60. And in this case, you will have just a second, please. This is gonna be 1, 2, and root 3, as you can see. So if I'm getting 10 of pi over 3, it's gonna be 1 over root 3. Okay? Am I right? No, I'm not right. I'm sorry. Please do forgive me. This is 1 and this is root 3. This is the correct ratio I usually get used to. So if I want to get the sine of 30, here pi over 6, it's gonna be simply 1 over 2. The cosine is gonna be root 3 over 2. The tan is gonna be 1 over root 3. And for pi over 3, which is 60, it's gonna be the tan root 3 over 1. Okay, so that's a major triangle I want you to keep in mind. Also, the 45 triangle, which is gonna be 1, 1, and root 2. If this is 45, which means pi over 4, so the tan of pi over 4 is equal to 1. Those are two triangles that we will be using so much in the coming period. Of course, you are right, Ms. Fatin, that we should also keep in mind that thetas is like this. In this part, you will have your theta running from 0 up to pi over 2, and here's from pi over 2 to pi, and here from pi up to 3 pi over 2, and here from 3 pi over 2 up to 2 pi. These are the angles. This is very, very important. And also, you know that all the trigonometric quantities in the first quarter are positive. In the second quarter, this is only just the sine. In the third quarter, you will have tan. And in the fourth quarter, you will have cosine. Those are the positive amounts of relative to quarters. Are you with me? Okay. According to all of this, once more, خلاص؟ ده معاك. يعني تراجع مثلث ال 30 60 مثلث ال 45 percentages والريشيوز بتاعته تحتاجهم على طول tan theta mainly cosine tan والكوساين you will need them. Also معايا مع دول ان انا عارف الكوارترز first quarter second third and fourth. What's the positive amount value of the trigonometric functions in the first is all of them. In the second quarter it's going to be just only the sine and the cosec. The sine and the inverse of sine, or the reciprocal of sine, which is cosec. Then in the third quarter, you will have cosine and sec. And in the last one, you will have tan and cotan in the third one, and cosine and sec in the fourth one. ماشي شباب؟ تمام؟ خلاص؟ Okay, very good. خلاص, now I know that tan theta is equal to pi over 6, as you can see. So theta is pi over 3, which is 60, or because tan is positive in how many quarters?
3.
The first quarter and the third quarter. So if it is your angle, if it is in the first quarter, so the angle will be pi over 3. And if I move to the third quarter, I will add 180. So it will be either pi over 3 or plus pi. Those are the two angles. Now I have no regulation on area Faisal. So if I want to write this equation in Cartesian, I will do it this way. بص ندى Princess بصي هكتب B ليه دي which is open X and Y, and it is equal to open R cosine theta R sine theta such that theta is equal to pi over 3, okay, or that's the sign of or 4 pi over 3, and R belongs to from 0 up to infinity. From 0 up to infinity. That's the representation of this equation in polar. That's the representation of this equation in polar. And that's the answer on the famous question, characterize the given equation misfitting. Okay? You know that I can read eyes. Consider the following subsets in R2. صح? In Cartesian mean coordinates. And characterize them using the polar coordinates. So if the question was like this, it means try to get the polar coordinates and write them on this form. معايا؟ انت فاهم يا فيصل انا كتبت ايه؟ مش صعب. انا كتبت اكس وواي وانا عارف ان البولار كوردينت اكس بيساوي ار كوزين سيتا وواي بيساوي ار ساين مين؟ سيتا. بعدين الايكويشن اللي فوق دي انت you can release r with each side صح؟ That means r is not a function with you. So r goes for forever. So r runs from 0 up to infinity. It's an open one. But you have how many thetas? Either pi over 3 or the other angle in the third quarter. Okay? So once more I can write it like this. طبعا زي ما انت شايف انا بس لازم انظف السكرين لان هي اصلا مش المفروض يتكتب عليها يعني. بس يعني احنا الحمد لله لاكي ان احنا بنعرف نريز على طول. طبعا ده واي 3 يبقى اذا باي اوفر 3 as I told you اور طبعا الرمز ده اور زي ما زياد عارف 4 باي اوفر 3 على طول الحركه اللي بعديها بص بكتب خلي بالك الاسلوب الكتابه ده هيكمل معايا على طول. ازاي بكتب بي such that x and y where x r cosine theta r sin theta and r belongs to the set from 0 up to infinity. I have no regulation on r. طبعا ايوه صح فاتن ايوه مظبوط. انا ممكن بدل ما اكتب كده انا ممكن اكتب r تناكه ممكن اكتب r belongs to r positive including 0 صح؟ انت فاهمه ده طبعا. هلو سيده والله مش تتخيل انا النهارده بدات الصبح قلت لهم مستحيل ابدا من سيده. راح قال لي لا يا عم سيده ايه وبتاع ابدا على طول كده يعني. and سيتا not سيدا and theta is pi over 3 or as I told you this is or pi equal to 4 pi over 3. معايا مس فاتن؟ مس ندى هنحل مع بعض البروبلم اللي جاي. اوكي؟ طب خلاص انا عرفت الفاليوز بتاعتي. طب بص بيقول لك هنا I need you also to characterize وهبدأ المسألة الظريفة دي. B from x y belongs to r square which is in 2 dimensions such that y is greater than or equal to 0 and less than or equal to x. يا ترى انا بلعب فين وبتكلم على ايه؟ يا ترى ده بيريبريزنت ايه؟ x is greater than or equal to y and y is greater than or equal to 0. يا ترى representing ايه؟ اللي انا كاتبه ده بيريبريزنت ايه؟ فكر كده. x is ايه؟ positive مش اكبر من الصفر. y is positive برضه اكبر من الصفر. ودايما الاكس هتوفركم او بتساوي مين؟ الواي فاليوز صح؟ ده اللي this inequality بتقوله. طب انا عايز اتشينج تو بولار كوردينتس. ايه اللي في ايدي؟ دي كارتيزيان اكس واي عايز اروح لبولار. ايه اللي في ايدي؟ ريليشنز بتقول ايه؟ لو انا اكس واي عايز اروح ار وثيتا يبقى انا عارف ان الار يساوي الروت بتاع اكس سكوير واي سكوير، صح؟ طيب وعارف كمان ان الواي بيساوي مين؟ يا ترى حفظتوه ولا لسه؟ ار ساين سيتا. طب والاكس؟ ار كوزين سيتا. Let's substitute in this inequality. That's what I have. I will start my solution by writing the inequality. Y is greater than or equal to 0 and greater than or equal to x. I will replace y by r sine theta and the x by r cosine theta. Here we go. So r sine theta is greater than or equal r cosine theta is greater than or equal 0. So I need to reach something. I will divide on r cosine theta like the steps that I had previously. If you divide this theta on r cosine theta, you will have 1. And this is going to be tan theta. That's going to be greater than 0. Am I right? Boss, that's the second step. Which means tan theta is less than or equal 1 and greater than or equal 0. مس ندى. طبعا لما تبقى tan theta less than or equal 1 and greater than or equal 0, tan 0 or tan minus 1, 0 is 0. Tan minus 1, 1 is equal to pi over كام؟ From the 45 triangle. عشان انا قلت لك لسه من شويه I have the 30-60 triangle and I have the 45 triangles. صح؟ Do I have any regulations on R؟ انت شايف الاكس واقفه؟ ما هو الار ده لينس. لما بقول x is greater than y is greater than, do I have a limit for the x-axis, y-axis? No. So in a similar manner, R doesn't have a limit. So R is open. يبقى representation for this part خلي بالك ده from 0 up to pi over 4. يعني يا شباب احنا لسه قدامنا كتير قوي قوي قوي، فلا تسرح ولا تمسك موبايل. قدامنا كتير، انت هتقعد معاه كتير لغايه لما يعني ريحتك تطلع يعني. ادا الاكس وده الواي، ادا الاكس اكسس وده الواي اكسس. لو انا بصيت على ده هنا بيقول ايه؟ انا بيقول واي جريتر ذان 0 اكس جريتر ذان 0. يبقى انا بلعب في انهي كورتر؟ خليكم معايا شغال دماغكم. فيرست كورتر. مش انت عايز ده؟ ده اكس اكبر من مين؟ 0. واي اكبر من مين؟ 0. بيتحقق فين؟ فيرست كورتر. بس عندي كمان كونديشن ان الواي از ليس ذان مين؟ يبقى اذا y equal x ده line. In this region, you will have y less than x. The border is equal to x on this line. That's what it does it represent. طيب لو انا عندي y is greater than or equal to x, Mr. Faisal, in this case it's gonna be those points. شايف البوينتس دي؟ دي البوينتس اللي انا بشاور عليها دلوقتي اللي فيها ال y is greater than or equal to مين؟ to x. Are you with me? Monsieur Faisal؟ تمام. طب لو انا بتكلم في r وثيتا، r from 0 وثيتا بتتحرك. How to cover the same region يا فاتن؟ عايز اكفر نفس الريجن دي. يبقى ده معناه بنبولر، يعني بالبولر معناه ان R هيبقى from 0 up to infinity، بس الانجل will move from 0 up to pi over 4 عشان يكفر same region. Are you with me؟ ها اتفضلي.
انا مش فاهمه ازاي رحنا من تاني ستيب لتالت ستيب.
من انهي تاني ستيب لتالت ستيب؟
اللي هي فيها ساين ثيتا اوفر كوزاين ثيتا بعد كده.
ما هو اصل احنا يعني ايه سابقين. ساين ثيتا اوفر كوزين ثيتا بيديلك مين؟
تان.
وكده تان ثيتا is less than or equal 1 or greater than or equal to كام؟ 0. take tan minus 1 for all of them عشان اجيب الثيتا. يبقى ده معناه ان tan minus 1 tan ثيتا is gonna be ثيتا less than or equal tan minus 1 greater than or equal tan minus 1 0. tan minus 1 0 كام؟ less than or equal ثيتا. وتان minus 1 بيطلع بكام؟ اللي هي بتساوي كام؟ صح؟ طيب اللي اهم من ده انه انا حاليا فهمت الريجون اللي فوق ده يهمني. الريجون اللي فوق هي عباره عن half of the first quarter. البارت اللي جنب الاكس اكسس. تعال بص كده يا فيصل، هتلاقي انه حاليا انا اقدر اكتب اهو، بصوا خلاص. هنا طبعا بيقول لك exist Q1 ودايما الواي اقل من او يساوي اكس، لذلك بصوا بحللها ازاي، كاتب ازاي. It is the set of x and y where x equal r cosine theta, y equal r sin theta، وده اوريدي انت حافظه مش كده؟ such that ال r no regulation، هو ال r ده دايما بيلعب من صفر لما لا نهايه from 0 up to infinity، بس مع الصفر لما لا نهايه دول and في كمان كونديشن ان ثيتا لازم تبقى اكبر من كام؟ من 0 وليس ذان كام؟ باي اوفر 4 عشان يجيب بس المثلث اللي احنا اتكلمنا عليه. تمام مستر زياد؟ قشطه. يلا خد من عبد الله واتكل على الله. خش على اللي بعديه. I want to represent or characterize Monsieur Faisal that x and y belongs to r square such that x square plus y square less than or equal to 3 greater than or equal to 2 and the x is less than or equal to 0. الكل بقى يفكر كده انا بتكلم على مين؟ نفكر. سيدة انت مستخبيه في ندى فانا مش شايفه. سيدة لو بصيت على x square plus y square less than or equal to 3 greater than or equal to 2. طبعا الكل بلا استثناء in the previous lecture we knew now that x square plus y square equal to 3, it's a circle. It's an equation of a circle. So I'm talking about the portion of a circle where r is running from 2 to 3. Actually it's not from 2 to 3. حد يقدر يقول لي ريديوسز هنا يعني ايه؟ او اقدر ازاي احول لبولر؟ ها؟ any ideas؟ انا عارف ان r يساوي السكوير روت صح؟ بتاع مين؟ x سكوير بلس y سكوير. يعني ده معناه صح مس جنى ان روت 2 less than or equal السكوير روت بتاع x سكوير بلس y سكوير less than or equal root 3. So r is less than or equal root 3 and the greater than or equal root 2. Are we right؟ صح؟ مظبوط؟ حلو جدا. طيب انا عرفت دول بس مع دول في كمان حاجه. خلاص كده انا جبت ده، يعني ده خلاص ده مسح، جبت ده مكانه. بس بص على الاكس كده، اكس از less than or equal to كام؟ فين السيتات اللي بتعمل ده؟ ما هو الجزء ده يتجاب من سيتا